Welcome everyone to the 6th episode of the MEAM Faculty Spotlight series by the Penn American Society of Mechanical Engineers. We will continue to host frequent faculty spotlights highlighting professors and faculty in MEAM that you've taken classes with, done research with, or maybe haven't, in the case of me, Professor Lucas, haven't gotten the chance to meet yet, at least in person. We've had the pleasure thus far of interviewing Professors Dustin Roberts, Jordan Rainey, Graham Webashevsky, and the beloved meme shop technician, Joe Valdez. But today we're particularly excited for this next interview.
So hi, my name is Ari. I'm here with Jason. We're originally from just outside of Philly, and we're both seniors this year. So we're one of the things that, thank you, that we as Penn students are most grateful for is the ability to come here and learn from and engage with incredible faculty. So we've been fortunate enough to get exposed to a wide variety of fascinating and practically useful engineering skills. So today we're going to delve into a unique discipline within MEAM, which is heat and mass transfer with an emphasis on nanotechnology. And we'll be chatting with someone who teaches a lot of relevant classes in that subject area, advises several undergraduate students, and does much, much more here at the university. So without further ado, today we're joined by Dr. Jennifer Lucas, who's a professor and researcher in the MEAM department, and who's willing to take some time out of her busy day to come and talk to us. So Jason and I have had her in class, but we've always been willing to learn a little more about her outside of that setting. So Professor Lucas, thank you very much. Welcome. Thank you for being here.
Thank you.
Yeah, I guess to start off, Ari and I kind of said, like, we have been exposed a little bit to your research interests and we had you in class, but maybe if you could just give like a broad introduction, like, we heard your intro over Zoom, but like now that we're together in person, or for anybody who hasn't met you before, just like 1 or 2 minute spiel on like who you are, where you've been, what kind of stuff you like to do in your free time or what you study.
Or lack thereof.
Yeah, I am a military brat, actually. My dad was in the Air Force. I lived a lot of places in the Midwest. And I settled in Texas at age 12, where I went to middle school and high school. I went to Rice University as an undergrad, and I chose mechanical engineering because, not because of my necessarily not because I had a passion for the discipline, but because I thought the mechanical engineering professors were the coolest. And at Rice, everyone came in like curriculum deferred. You were in engineering. You were not assigned to a particular major yet. And so they had this thing for freshmen where you would come in and you'd go around and you talk to the different faculty. And I talked to different disciplines, and I felt like the mechanical engineering ones were the more sort of normal. And I felt like that was easier for me to identify with somebody who just seemed like normal. I don't know, not to throw shade on the other disciplines, but I felt like I could connect with those faculty. And so I joined that program, and then I just sort of went through the curriculum. And then after doing my bachelor's degree, I got a job in the oil and gas industry, and I quickly realized that wasn't what I wanted to do. And so then I decided, okay, I want to go back to school. And so I ended up trying to figure out what I wanted to do next. And I talked to one of my undergrad professors who said, oh, you should go to Berkeley and you should work with this professor, and I was kind of clueless. And I said, okay. But I realized though that I wanted to get a PhD because the people at my previous job who were doing the coolest and most interesting stuff to me, the things that were most interesting to me were, they all had PhDs. They were all working in research and development. And I said, because that was the most interesting thing to me, I said, okay, I need this degree in order to do the things that I find more interesting. And so the job wasn't a bad job. It just wasn't it wasn't a good fit for me. And so I wanted to get into more researchy stuff. And so then, so I got into Berkeley and decided to go there. And, it was tough. I mean, moving away from my family, first year was really hard. It was really, really hard, just because, I didn't know anybody there. And, and it really gives me a lot of respect for international students who are coming from all over the globe. I mean, I just moved halfway across the country, same language. I mean, everything the same. And I just, having people who are coming from, all corners of the globe, and it just, the challenges that they face every day. And so it really gave me a lot of respect for students who are coming from, different international locations. And so then, so it was tough at the beginning, but it was the right choice for me. And so my advisor was Changlin Tian, and he was this really famous heat transfer guy. And he, in fact, was also the chancellor at Berkeley when I joined. And so chancellor is actually the president of the university. It's what they name the president. So every campus has a chancellor, which is their quote unquote president. And then, so it was very interesting working with him. He had incredible energy. He was flying all over the globe trying to raise money. You felt like you couldn't waste his time because, he had to raise like $500,000 a day or something. And so you just, you don't waste his time. So you're very organized. You meet at strange times, because that fits, to his very busy schedule. But it was a good experience for me. And then I applied, after like finishing my PhD, I was applying to faculty positions, and I wasn't sure if I wanted to be a professor. Like some people have known, like from day one, I wanted to be a professor. All I knew was I wanted to get a PhD because I knew that you could do like research, and that was the most interesting stuff to me. And so, but I didn't know what I wanted to do. Do I want to go and work in research and development in a company? Do I want to work for a national laboratory? Do I want to be a professor? Do I want to, go into like a nonprofit? Like what kind of things do I want to do? And so one thing that I learned that I would really like advise people to do is to really take stock of what your interests are and what your passions are, because I think as an undergrad, I just went through the motions. I did this major because, I love the major, but I chose it for kind of not the best reason, but I'm glad I chose this major. But I feel like having a little bit of forethought, like I said, I'm going to be a mechanical engineer, and I sort of checked off all of the coursework. There's a schedule and you take this course at this time and you do all of this. I didn't really think like very far ahead, like where do I want to do? What is the most important thing? And so then when I got to the job at the end, and like, but I hate this job and I feel like I'm in jail. And I just like, I never really thought about what was interesting, because it didn't occur to me to even do that. And so I really think one thing that I'm very, very passionate about is that, trying to help people figure out like what is their path in life, like, because I went through that struggle myself, and even in grad school, like I knew I was in the right place, but I didn't know what I wanted to do afterward. And so it's really, really important to pursue your passion. Like what do you love? Like what is stuff, like what is a hobby? Can you turn that into a job? Because that's really an important thing to do, because then you'll be sustained like throughout your life and throughout your career. Whereas, so if it is possible to follow a dream that's your passion and get a job in that field, you should definitely try, especially when you're young, because when you get older, you have more responsibility, and it's harder. But of course, there's practical realities, like you may not be able to get your dream job. You have to put food on the table, whatever. But if it's possible to try to do that, it's really, really important. And also to talk to people. Like if there's a job, if someone's doing a job that you think is really cool, you want to do informational interviews. And I don't know, in career services, I don't know how great they've been. I think maybe they're better than they used to be, but in supporting people who want to do engineering careers. But I think, this thing where you're talking to somebody who's doing stuff that you love, and like figure out what is their path and how do they get to where they are. Like, do you have to, do a certain internship or get a certain degree or whatever. It's just like looking farther ahead is a really, really important thing, I think. And I personally, I didn't do it enough until I got to a situation where I'm like, I hate this job. Like, I really want to do something else. And so I really encourage people to really think carefully about, what they're doing. And so then I came here. So my advisor, he's this very famous heat transfer person, and he, designed some of these like space shuttle tiles, like for example. And like when I was a prospective student, they took you on like lab tours and stuff. And I went in, and like some of the current students in the group, they pulled out this space shuttle tile, and it was like this big. And it's this very, very good thermal insulating material. And it's like, he worked on that stuff, and he pioneered a lot of very interesting things like in thermal radiation. So hopefully you remember from 333, that you have this T to the fourth, like radiation sort of behavior. And, but he found that actually when you get really, really close, he was one of the early people that are saying that when you have this near field radiation, when the surfaces are super close, you get much higher than Stefan Boltzmann, which is the T to the fourth. And nobody believed him for a long time. And nobody believed his grad student, the work that they did. But it turns out now everyone's doing near field stuff. And it's like, he was just like, several decades too early, but he did a lot of heat transfer stuff. And looking at things at small scales. And so that's kind of how I got into sort of my research area. So he always told us to look into things at the extremes. And so, look at things that are really big or look at things that are really small, because everything in the middle, people have already kind of looked at, And so this is why we sort of do this sort of micro or nano heat transfer. Like when you're at very small scales, things behave very differently than they do in our everyday experience. We have a chunk of material, it has a known thermal conductivity, we look it up in the back of the book, and that's the number, right? But when you shrink things down really small, you start to move away from this continuum assumption. And what that means is that the actual properties of your material are no longer intrinsic, but they actually depend on the geometry of the materials. And so like one of the things that I've looked at a lot is like, how does the shape and geometry and size of different materials affect their thermal properties? And so we do a lot of theoretical modeling and figuring that kind of stuff out. And then another thing that we're interested in doing also is looking at like liquid vapor transport processes, because one of the things that's one of the biggest climate questions is how do clouds form and how do they interact with radiation? Because one of the things we talk about a lot is these energy balances. And so the Earth's global energy balance is based on the balance of what comes in and what goes out. And the clouds really impact what's going on with that. But one of the biggest questions is all of the smog, all of the particles, all of the soot, all of the aerosols in the atmosphere, they serve as nucleation centers for droplets. And depending on what type they are, what kind they are, that determines if the water vapor in the air can have this condensation onto them. And so there's a lot that's still not known. So the particles themselves directly scatter radiation or reflect it, but it also determines how droplets form and clouds form. And so there's this sort of secondary effect of these aerosols that are in the environment. And so one of the things we're developing computational methods to look at more recently is like, how do these tiny particles in the atmosphere, how do they condense water and how fast do the water droplets grow? Because for certain types of aerosol particles, it's really not well known. And like the connection between the aerosols and the clouds is one of the hugest unsolved questions in these global like climate models. And so it's kind of funny because you have these global models that are predicting like weather patterns and like climate like over the whole globe, but it's affected by these really like tiny like submicron particles or like, tens of nanometers, up to, a few microns. And so this is another sort of example of like looking at really tiny stuff and like its transport properties. So this is more of a mass transfer problem and a condensation problem, but that's some of the kinds of things that we look at.
Wow. Yeah,
I've talked a long time.
No, that's good. That's exactly what we wanted, and honestly, we've never really heard this kind of depth from you before, at least like your life, your teaching, your research. So it's really cool to just hear it all in one go. One thing that really stuck out as interesting was you had said that your advisor said everything in the middle has been seen before. So you have to look at things really big or really small because that's like more new and exciting. And I guess like kind of honing in on that point of like new and exciting. Like I know that you said that you like came back to school to pursue a PhD, like not necessarily to become a professor, but because of the research, kind of like that idea of like delving into the unknown, Can you speak to that a little bit? Like what like additional sense of satisfaction there is in doing something novel that hasn't been done before, but also maybe like what challenges there are, like what kind of problem solving things arise when like you are at scales that people just have not explored before, and there's like no template for like how do you do this,
Yeah. So I think, in terms of the research thing, I think that's why it's really important. And one thing I've learned is that people really need to like have their inner compass and know what's important to them. Because one of the problems I worked on when I was in engineering industry, which I was only in industry for a year before I went back to grad school. But one of the important problems is with these natural gas wells, you put them on line and then they connect through different pipelines and they come to this facility and the gas gets processed and cleaned up and then it's sent in these like giant natural gas pipelines that go across the country. And it was so fascinating because if one of them comes offline, it affects the pressure and the pressure ripples down the whole network. And I built like this cool like computational model of like how all the wells were connected. It was like it's like a fluid mechanics like pipeline network diagram or something. And like, if you put this one at a higher pressure, you get all of this extra flow in the system. And I was so excited about it. And nobody cared. Nobody cared. They thought, okay, will it make us money? And that's what they, and it's a business, right? I mean, that's their job is to make money, but that wasn't, I learned early on that is not what motivates me. It's actually finding new things, finding interesting things. And so I just, trying to figure out new things. And so when I was in my job also, I felt like I wasn't using the things that I had learned I felt like I didn't even need an engineering degree to like do the types of things that were being done. I don't know. I felt like it wasn't going into enough depth, and maybe that's because like Bryce had a very rigorous education. But it's not that it was a bad. It just wasn't a good fit for me personally. So that's really important is for people to identify what they want to do. And so then going into the PhD, so I knew like I'd had some professors when I was an undergrad say, you should consider a PhD, and I'm like, I'm tired of problem sets. I'm tired of studying. Like I don't want to take any more tests. I just want to get a job and make money. But I realized that actually, once I actually did that wasn't the right thing and that they were right. But, no one can really tell you what to do with your life. You have to figure it out for yourself. But I think really like what I learned is people should be very, listen to your inner voice of what it tells you that fulfills you and then follow that, whatever that is. And so for me, it was the ability to study new things, to learn new things. And that's what research involved. And so research is very, very different from anything else. It's very different from undergrad. It's a completely different thing. You still, as a grad student, you take courses, but the courses are to prepare you for independent research because you're the one figuring stuff out. Like there's textbooks that kind of prepare you and you take courses to sort of set the foundation, but ultimately it's a synthesis of new knowledge. And so, and it can be very lonely because you might be like one of like 3 people working in a specific area, and like if you get stuck, it's like there aren't many people that can help you. It's not like your undergrad class or like, you have older classmates or like your other classmates or whatever. It's like you're working on this very focused, very deep research topic, and there's not a lot out there. And so one thing also is that you need a lot of resilience, right? Because getting a PhD it's not really about, the academics, of course, is very important. You need to get, good enough grades and that can demonstrate that you're able to like learn material and like figure stuff out. But it's the independence and it's the ability to overcome obstacles, which it's, like my advisor, for example, he got sick like during my PhD. And at another time, he was being considered for Secretary of Energy. And both times I'm like, am I going to have to find a new advisor? That would mean starting all over. And when you have invested a certain number of years like into your program and then to have to start a completely new project, so it was like terrifying, the thought. It turned out that I didn't have to do that, but there are a lot of obstacles that people face. And this, of course, obviously is not just in a PhD or in research, like people face different obstacles, but like, I did not realize like how much perseverance and like grit and the ability, because in research too, like you have all these ideas and you make a plan. Like one of the things is you make a plan for like what you're going to work on for your project. Any sort of big project, you have to have a plan. And one thing I learned is you make your best estimate of the plan, and then you add at least a factor of 2 or more. and that's how long it will really take. You know? And it's realism, but it's just it's so important to build up that perseverance and keep getting back up, because more things go wrong than right. So that's why you have to have that passion for what you do, because it'll see you through those difficulties that will inevitably happen.
That was one thing that kind of stuck out to me about Penn and really college in general, that like you come in expecting to like keep developing knowledge and thus like performing tasks more easily, like with less obstacles, because you figure like, oh, I know so much, like I've done everything already, like I can now like have this toolkit to solve any problems that come my way. But in reality, it's kind of the opposite. Like you are learning a lot, but the problems are also getting harder at a faster rate, such that oftentimes it's not even as much about like what from my toolkit can I pull versus like, how can I like iterate through possible solutions, knowing that I'm probably going to fail like at least 4 times before I succeed, like kind of accepting that idea of like learn from making mistakes versus learn from just this like body of like lecture content that you've acquired over the years.
And actually that's why senior design is so important too, I think. I just feel like that's a really important thing, because you have these plans and then like usually something always goes wrong, and so it's kind of gives you a taste of it, of what that's like. But it's really important.
Yeah. And I don't know if you know this. Well, so we talked a lot about your research, but you started talking about that and talking about finding your passion and perseverance, talking about teaching. And I'm not sure you know this, but your teaching like style is very well thought of among the MEAM undergraduate class. We really appreciate the way you teach. It often involves a lot of lasagna.
I'm sorry, the lecture,
But but you started talking about finding your passion, and the way that you approach teaching is much more of a holistic and humanistic, I think, teaching approach than we see a lot in a lot of STEM fields, especially at Penn. When you're, when you're interacting with students, when you're preparing for lessons, what's your teaching principles? What's your approach, or just to being an advisor and a professor to students who are going through the path that you're describing?
Yeah, I mean, I think that I try to look at it like, how does this relate to people in real life? I think like when I started, I don't know. It's kind of the way I was taught was sort of, you go to the classroom, the professor writes a lot of stuff on the chalkboard, you copy it down. Nobody really asks questions, and I found myself like, it's kind of funny, but I found myself as like one of those kids that went to class, and I felt like I didn't know what was happening. I was just randomly copying or frantically copying and trying to make sure, and then I would study it and try to figure out later. But I think it would have helped like a lot. I think if I'd seen some examples, like more examples of like, I'm doing all these derivations, like, what does this actually mean? Like, what is it? And so trying to help people make the connection between like some equation and like what it actually means in real life. And I think that then I think it can somewhat become more real to people. But different people are motivated by different things. And so what I try to do is like put some pictures. Also, some of you probably have seen me attempt to draw pictures on the board, or actually, Jason, you didn't see me at all on the board, but like draw it on the iPad. Actually, did I have the iPad? No, I didn't have the iPad. I got the iPad after because everyone complained about the document camera. But iPad is so much better. Yeah,
I think I did see you on the iPad by spring 2021. I think you had it. He had you spring 2021.
I had you.
Okay, yeah.
For reference, both of us had Professor Lucas over Zoom during COVID, so various learning strategies were attempted.
Speaking of iterating 4 times until something works.
Yeah. But it's so much nicer though. The iPad is so much nicer. So it's totally
agreed.
Totally. But I think it's trying to make a connection to like a real thing, because I feel like sometimes we sometimes we can get very sort of theoretical and into what we're doing, and it's totally clear to us. But for somebody who is new to the field, hasn't is just learning this stuff, like what does this equation actually mean? Like what does it do? And so it's sort of trying to somehow connect it to a real thing that people can at least see, like why are we doing these calculations and like what's it for? And I think especially because I feel like, the thermal fluids, like, get some of a bad rap because like now, all these people want to work in robotics, and robotics is great and there's a lot of things, but like, we're really central to like, issues of like energy and climate and other things. And I think there's a lot that can, that we can offer. And I think trying, especially to pull those examples of things that are really, really relevant to people right now is important. The temperature of the earth is a giant energy balance, like energy balance, energy balance, energy balance. That's all I talk about because that's like the single most important concept, like in the class, but it determines the temperature of the earth, in minus out, like it's all in there. And so, and this sort of condensation processes on these aerosols. And, we've had seminar speakers who have talked about like extreme, like global events, like weather, and what the impact is on cities and buildings, right? Yeah. So you get these more extreme weather events, and the buildings and the infrastructure is not designed for these situations. And so, we had a speaker came in and does like computational modeling of like these wind gusts and these extreme storms and stuff. And so we'll have to like think about like how to make a more resilient infrastructure as well, and figure out how to deal. So the fluid mechanics of this, of these extreme wind events and these extreme weather events is really important as well. And so I feel that, I think that the thermal fluids is really important for, understanding some really important challenges that we have. So.
Yeah, I guess kind of responding to that from the student's perspective, because I had you in class, like we really appreciate that teaching strategy, as Ari said, for a couple of reasons. Like one, just by teaching in a more like application driven way, like what do these equations mean, as opposed to like, write this down on your cheat sheets kind of thing. Like it just keeps things interesting. Like we had a lot of obstacles from our learning in our 4 years, like COVID, everything. So keeping things interesting and students being engaged, like it helps people come to class, helps people be motivated to say like, wow, I'm going to learn something cool today. Like as opposed to like, I have to go to lecture. So that's definitely one benefit. And then also just like, as you said earlier, like, learning from a classroom kind of just got boring for you at a certain point, like, and it does for a lot of students. And so that's why you go out into like application and research and like really go do something new. And like teaching in an application driven way, like working through problems and like drawing pictures, like that kind of thing really helps us understand like, what is this for? Like, why are we learning this? Like, not just to go teach it to somebody else in lecture, but rather like to apply in various different settings. And I just, speaking on behalf of the whole student body, we really appreciate that. And like for anybody else who's interested in teaching or like has taken classes before, I'm sure you would probably agree with that, a more hands-on application driven education is one that at least we resonate a little bit more with.
So a fun question spinning off of that. We know you alluded to this before. You have kids.
Yes.
You're a mom. Well, first, is this teaching approach informed by teaching little kids like how to be in the world? Also, like tell us a little bit about them. How old are they at this point? Because when I saw you on Zoom, they were just these like tiny children, like zooming around in the background.
That was Nina. Yeah. That was yeah. So I have a 13-year-old. And I have an 8-year-old, and the 8-year-old 2 years ago was 6, and she was the one that was like occasionally would wander into the camera because of course it was COVID and she was at home, and I was trying to do her Zoom school as well as my Zoom school, and yeah, it was that was not a fun time at all. Having kids, like school age kids, like young school age kids home from school is very difficult. So, but I have 2 daughters. And one is an 8th grader and one is a 2nd grader, and I don't know, they ask really good questions, and it's just a way of looking at the world that is it's so she, my younger daughter was learning some like water cycle at school and like talking about like the rain falls onto the mountains and then the mountain, it all comes downstream and then evaporates and the cycle just continues, and and I was telling her that, that's, we talk about that in my class too. And then my older daughter came to me and she says, yeah, I checked you, I Googled you and I checked you out, and like, you teach all of this interesting stuff. Like, she just knows me as like her mother. And, but she Googled me and she's all this kind of stuff. And she said, wow, you're professor of Penn, that's pretty cool. And, 'cause I mean, when I interact with them, it's a totally different thing. It's like, like even in my own family, like when I was in grad school, it's like they never thought of, they never viewed me in that way because that's not my relationship with them. It's just like I'm the daughter or I'm the sister or whatever. So, or the kid. But you know, I think I always try to encourage them in math, especially because I feel like math is the universal language of like all technical disciplines, and I can't push too hard for them to become engineers because if I push, they're going to go the other way. But I try to. And another thing that I really try to do is I try to instill in them the ability to sort of realize that you can face hard things, like the things that I'm most proud of them for, or for doing things that are hard. Because there's a tendency to coast. You know, if things are too easy, you're not challenged, you don't develop the ability to bounce back if there's a problem or if there's a challenge. And so, and you know, I have perfectionist kids, just like their perfectionist mom, and that can be a problem though, like if you feel like you have to get everything perfect. And we see a lot of that. Actually, we see you know, a lot of challenges, like is like everyone like at Penn, like, you know, they were all like top of their class, and then they come to Penn, and like some of them for the first time are finding things that are hard, you know, people who have coasted through with little effort, right? And so then when you come to a situation, and then there's like this pure panic, and so I, you know, just trying to instill in them the ability to like, you know, work a hard problem or something that scares them a little bit, is just to take baby steps toward that. So I mean, because I see that all in life, like resilience and grit is really important in life, like in general. So it's hard because people are afraid to face things that are scary, but you don't learn and grow until you actually do that. So
yeah, that's great to hear. Like I know earlier you talked about how you kind of like took a little bit of time to find your footing, like when you first got to Berkeley, and then like when you got to your job, it wasn't really what you expected, and kind of just like rolling with the punches, you know, kind of figuring it out as you go, just knowing that you're going to fail a couple times before you succeed.
Yeah.
And it's great to see that you kind of like helped cultivate that mentality in your kids, you know, like sure they're young, but like us as students now, like some of the things that Ari and I, I'm sure, like appreciate most from our childhoods are the failures, kind of like developing that robust toolkit to kind of like face anything that comes your way, as opposed to just like doing well in everything and like being told explicitly how to do things right off the bat. It's more about figuring that out, you know.
And that's really, I think that's really important for incoming students to know, and not just incoming, but all the students to know. I think once you've been here a while, you get sort of more used to how things are, but it can be a real shock. I mean, just, you know, advice. I don't teach any freshman classes, but, you know, having freshman advisees and some get really stressed out, and it's just, and, you know, even me, like going to grad school the first year was like totally different and very stressful. And it's just, you have to find your way, but realize that you're going to get things wrong, you're going to mess up, and it's okay. And you just have to keep coming back. And if you need help, ask for help. That's a really important thing as well. Yeah. And one thing I found is that, there's a lot more stress. Like from when I first started here, I just feel like mental health concerns, like and maybe nobody talked about it before, but I feel like students are more stressed now than they used to be, like when I started. And I don't know what it is, or maybe it's just people are more open about it now, which is a good thing. You know, but it's just, I think we really need to, you know, tell people that it's okay, because there's so much perfectionism, and there's so much like people are just very stressed and trying to do like everything to be super perfect and super overachiever. And you know, you have to take care of yourself. It's really important to maintain. I don't know, it's just people put a lot of pressure on themselves, and it's, I don't know. I think that we have to sort of recognize that people need to recognize, like in themselves and in their friends and just, you know, people in the community, like, you know, when people are stressed, you know, we really want to reach out to them and make sure folks are okay.
Yeah, I think that's great to hear from you, especially because like for Ari and I as undergrads, like as you said earlier, a lot of us like did very well in high school. Like Ari and I went to the same high school, we were the top of our class. And then we get here, and if anything, we see like well-established professors like you, and you know, you guys are doing so well, doing so much cool research, and we say like, wow, like, are we going to get to that point? Like every failure feels magnified because you realize you have so much more to climb, you know. So it's really good to hear that message, like from you of all people, like having made it, so to speak, that like everybody like doesn't have to be perfect, like you, just because you may have felt perfect back in high school when like there's less you're really asking of yourself, like now you don't need to get 100 on every exam or like get every job offer or anything like that. Like you don't need to put all this pressure on yourself. You can fail. It's gonna be okay. Like you can have that conversation as well. Like mental health, I know worldwide, like I've been reading reports on this, like in the time of COVID has definitely gotten worse at Penn, especially. Like it does not have a great reputation in terms of like mental health among students. So I think that's something that we as a community have to kind of do better to support one another. Like if you see somebody's going through it, like support them. If somebody is like stressing out over like getting like every single thing perfect for a project, and like in engineering, when like a number of things can go wrong, it's very easy to get caught up on like I have to make sure every single detail is right, and then it drives you crazy. So kind of like taking a step back and looking at the bigger picture, like what am I trying to learn from this? Like maybe I'm not going to get everything perfect, but like what is the threshold of which I will still be satisfied with imperfection? Like asking these kinds of questions as opposed to just like always shooting for the stars and settling for no less.
Right. It's really important because it doesn't get easier because, when you finish undergrad, then you go into your career, or then you go to grad school, or then you go to, whatever your next thing is. And like, if you're trying to like rise to the pinnacle of your profession, whatever that is, then like everyone's going to be even better and better and better. So you gotta like learn how to, you have to learn to let go of the need to get everything right. And, and it can be a struggle, right? Because you're used to like doing everything, best.
Yeah, and that's the other thing. Like, if you're always shooting for like the next thing, then like you never take a second to appreciate, like, wow, I did this really cool research project, and I should just take a second and appreciate the hard work that I put into this and the people who I worked with and like got closer with along the way. Like, if you always do one thing and look at the next thing and like are always trying to ascend, then like, what's really the point then? Like, it doesn't really get you anywhere unless you like appreciate the work you've done and kind of keep track of that bigger picture.
Yeah, and I mean, Jason and I have felt this pressure and these challenges. And if we could ask a bit of a harder question, you're a young Black woman in the field of mechanical engineering. You've been here at Penn, you've been in California, you've been at Rice. I mean, it must be different environments and different challenges at all different places. Penn versus other places you've been change over time because I know that seeing you in the classroom has been really important for classmates of color of ours, women in MEAM. How Penn versus other places that you've been in your experiences over time, becoming really successful.
Yeah, I mean, so I would say, I went to high school and middle school and high school in Texas. And so, when people say things are bad right now, I kind of internally chuckle a bit because, I guess it's definitely harder. It was harder earlier on for sure. And, I would say that, for example, when I was interviewing for jobs after my, when I was in my senior year at Rice and I was interviewing for jobs, it's like, I would show up to an interview and like people would stare at me like I was this completely like alien object, like, like they didn't quite know what to make of me, right? And they didn't quite know what to do with me. And so I think the thing is, this is a kind of another reason why, you want to pursue sort of your passion because there are obstacles of different kinds that you may encounter. It's also important to, find people who've gone before and try to, reach out and like, try to find some mentors, for example, who can help you along. Berkeley was totally fine. It was a little bit of a culture shock there too. I remember taking a class, where it was all male students. It was like I was in a class of about 150. I was the only female student in that class, the only minority in that class. And it's just like, okay, but and it's you just do it, but this, but I love what I do. So like I had to, deal with that, and you can make friends. You don't have to be around. I mean, you can make friends with people of different genders, different races, whatever, and you can thrive. And so I feel like you have to be driven, and having a community, like a supportive network of folks that you can have is really nice. Another thing at Penn. It's really interesting for me to hear that people like my teaching style, because I when I first got here, people didn't like me, and in terms of a lot of students, so it's very interesting for me to hear this now, because I have not heard it since about maybe the past like few years, right? And so of course I have done things differently too, like when you start out you're new, and I've sort of evolved different things as I've gone along, but I remember, I think my very first year teaching, I got some really snarky subtly racist comments from students who were in my class, and so that was so the student body has not always been as sort of welcoming to me as they used to be. Another thing that you might have seen or be aware of is like the whole portraiture in the town building, and so you walk in, and even my husband noticed this too, you walk in and it's like these like old dead white guys from like the 1850s, right? Like their portraits lining the walls, and it's just like it's sort of designed to make you feel like you don't belong, and there are reasons I think they have to keep, for whatever reason, some donations for from those people or whatever. They have to keep the portraits somewhere, but they move them out of the first floor hallway and they put them in different places somewhere else, because they have to keep them. But it's not like, I mean, these are important people in the founding of our school, so it's important to have them. But like you walk, and you just walk down this hallway, like nobody looks like you. And so now, like, so they put in these different in the first floor now, like there's even a picture of me like with one of my students, like one of my PhD students from like 8 years ago or something, up on there. And so they're trying to make it show sort of maybe a more diverse set of people who might be in the school now. But I think that the attitude toward me from the students has gotten better, and like coming to Penn though, like Penn was a place that was like I remember interviewing at different places, like even with my PhD, and like I interviewed at some different places, and you could tell differences in the climate just like when you visit a place. Like you could set foot in a place and your radar, your antennae are going off, and you kind of really know, like, you get a very good sense of what a place is like. And so I just remember going to some places and just like, I could never work here or I could never go here. And so, but Penn actually, Penn was probably the best place in terms of the climate, like in terms of when I've interviewed at different places. And so I have to say that it's the places I've been before. I think Penn is actually better. So
Yeah.
So I think but I feel like the attitude from the students has gotten better over time, and maybe that's because there's a more diverse student body that we have now than we had in the past. That just maybe that's not the reason. I'm not sure. It's also because I've probably become a slightly better teacher. But yeah, I think that I think Penn is a good place actually. No place is perfect, but I think I've been other places. And
Yeah.
Trust me, it's
I guess
I've
that
been in an
is-
oil patch in East Texas, so
Yeah.
where there's like active clan members, like that are working in the same place. So yeah.
I guess that is telling of like, in part the progress we've made, but really the progress that still must be made. Like you're saying that Penn is imperfect and has like all these like portraits of like old dead white men like on the walls, and yet like even despite that, Penn is one of the better places. Like how bad does it get now that we're in 2022 and still facing some of these obstacles? like these are the questions that I guess it's good we're discussing because there are steps that still must be taken. But I guess back to your point that I feel like this has come up a couple of times. It's really important just about that resilience that like all these obstacles that come your way, whether they be in the classroom setting or in the way you're viewed, like it really just comes down to how resilient are you, and then like how do you achieve that resilience by caring so much about whatever is the subject area at hand. Like that's kind of what keeps driving you even through the obstacles. I feel like that's just a recurring theme that really has come up in a number of contexts now.
I had no idea like how important like resilience and bouncing back, and like you get knocked down, you get right back up, and you keep pushing, and but you have to take time, take care of yourself, nurse your injuries or whatever, but then come back into the fight, like, and it's not a fight, but just like keep, you're fighting your dissertation, like dissertation, please write yourself, like. So.
Thank you for sharing those experiences about resilience in your own life. I guess kind of transitioning from that, like you had mentioned earlier that it's it's so like impactful to see all these international students at Penn and the diversity. Like you said, you felt like it was a big adjustment going from I think Texas to California, right? So like for like some classmates of ours come from like Argentina to Philadelphia, I'm sure you remember Andy.
How could I forget? I mean, seriously.
And for these people kind of like making similar journeys as you made, in some cases even further geographically, but just different really, like what has been your observation about the way that they've faced some of these struggles, kind of analogous to what you faced like a couple decades ago, and then like just the sense of like seeing their growth, because some of these students you saw come in as freshmen and make that adjustment, and then now they're like graduating in like 2 weeks when we are, like kind of just crazy. Start to finish.
I would just say it's like any struggles that I faced, like they faced so many more, because there's a language barrier, there's like cultural differences. It's like you're, many miles from home. It's like, I could at least take like a 4-hour flight home or something, and they're like traveling like a whole day, so I just feel like I just think that like if you're going to a school, it's like sort of like to go to undergrad, like you have to be you're one of the best from your high school class, and then to go to grad school, you're one of the best from your college class, right? And then you have to learn another language, demonstrate fluency in that language, because you won't get, there's this, you have to pass this English test before you can get admitted. And so if you're coming from a country with a different language than English, which many of our international students do, and then you come and it's like the food is different, and like, it just, everything is different. And so I think it's, the people are really brave, I think, just like to be able to get up and go somewhere so far away. I don't know, I find that, when I would think about like challenges I would have, and it's like, I'm in the same language and the same country still. So I really can't really complain.
It really broadens your perspective, because like Ari and I, being from 40 minutes away and being like straight white men, like we come in and hear you talk about your experience, being at the intersection of multiple identities, like, and you said being in a class as the only female in that class, and we say, wow, like she has really been through it. And then hearing you say like these international students have faced everything you faced and more, like everybody kind of just sometimes loses track of like where they are on this whole like spectrum of like various groups people are part of, various things they've been through, like times in which you're alive. And so it's good to talk to people like how we're talking to you right now, and we learn like, wow, like maybe we had it easier, we should more appreciate some of the things that we have, and like just everybody in general can kind of broaden their sense of like what else is out there, where are these people from, and that's really like I think one of the benefits of these kinds of conversations, because that really just helps you get a sense of what else is out there, like people who you may have seen in a classroom setting, like what obstacles did they face before they got to the same point that you got to on your own journey, like I think of Penn really as like the intersection of like so many of us from so many different places studying so many different things with so many different aspirations for the future, who just happen to intersect at this point in time in this place, so it's just really cool to kind of like look at everybody else's path and say like, oh, like how did they wind up here, but like we're somewhere else different in the past, and where are they going, and like how can I learn from the challenges they faced, or like how can I study with them and become better students and engineers together, like there's so much that you can get from talking to people. And like to your earlier point, like so much of it comes down to learning what you love, and like you can't really do that unless you get your feet wet, go talk to people, like hearing about your research experiences, like seeing what your students are working on in class, like it's just really great to kind of keep an open mind. And I think at Penn, there's so much that exists here, like so much diversity, like racially, academically, that can really help broaden your perspective a little bit. And it's just great to take it, it's there to be taken, just talk to people, study things, join clubs, so that's just some things that I've kind of been thinking about in my couple of years here, and especially during conversations like this.
And your undergrad connections, like, you go to grad school, but like, and I keep in contact with, some of my grad school classmates, but like your undergrad classmates are really the most like tight, like, I mean, we have friends from like long ago. And, and it's just like, it's like, you haven't seen them for so many years and then you talk to them again, and it's great. So like, you really should also, like you said, like join the clubs, make those connections, because it's really going to serve you well later in life, because it's not all about the academics, right? It's about the clubs, it's about the connections that you make. It's really important.
Recently heard Penn described as the broadest cross-section of nerdiness that this individual had seen when he was visiting.
Oh, that's great.
Campus.
I love that, actually.
Yeah.
Rice was very nerdy too, and I appreciated that. I nerd myself.
Yeah, I guess we had kind of come up with a couple things we thought would be curious to hear about, and we pretty much hit them all. So
Okay.
on that note, thank you so much for spending your time with us. Thank you for opening up about such a broad variety of subject areas, and being honest with us about your experiences. To anybody still watching, thank you very much for tuning into today's episode. We were fortunate enough to be joined by Professor Jennifer Lucas. Again, I'm Jason Friedman. I'm joined by Ari Bortman, and we're signing off until next time. Thank you.